A common pool shot involves hitting a ball into a pocket from an angle. Shown below, the cue ball hits a stationary ball at an angle of 45 degrees, such that it goes into the corner pocket with a speed of 2 meters per second. Both balls have a mass of half a kilogram, and the cue ball is traveling at 4 meters per second before the collision. We're calling this collision is elastic. Calculate the angle with which the cue is deflected by the collision. But first, we are going to figure out what we know. So, we know that the velocity initially of ball number 1 is 4 meters per second. We also know that the velocity final of ball number 2 is 2 meters per second off 45 degrees. We also know that the mass of both balls is 0.5 kilograms. Now what we need to do is split this vector, the 2 meters per second, into an x and y part. So, if we draw out this vector, we have our 2 meters per second, and this will be the x part, and this will be the y part, and this is 45 degrees. So, with what we have here, we can solve by using the sine of 45 degrees equals the opposite over the hypotenuse. Then we multiply both sides by 2. 2 times the sine of 45 will equal our y part, which is square root of 2 equals our y part. We can do the same thing for the x part, except we can use cos because it's the adjacent angle. So, cos of 45 equals our adjacent, our x, over our hypotenuse 2. Multiply both sides by 2. 2 times the cosine of 45 will equal x, and is the same value. We get the square root of 2 equals x. So we can go ahead and say that this is the square root of 2. That is also the square root of 2. The units of these are the same as this, meters per second, because it is velocity. Now what we can do to calculate this here, the other vector, is we can arrange it in both its x part and its y part. So we're going to start off with the x part. So we know that the sum of the momentum before equals the sum of the momentum after, because this collision is elastic. This is the, we're calculating the x part right now. So this formula for this is m1 times the first velocity of 1 plus m2 times first velocity of 2 will equal the mass of the first one times velocity of the first one plus mass of the second one times velocity of the second one. The mass of the first one, we know the masses of all of them are 0.5 kilograms, and the velocity of the first one, well, this is in the x part, so we can see all of the velocity of the cue ball is in the x direction in this problem here. It is all going that way. So we can multiply it by our 4 meters per second. Plus, the mass of the other ball is also half a kilogram. And its velocity, well, it is stationary, so it is 0. And this will equal, mass of the first one is the same as before. The velocity we don't know, plus the mass of the second one is the same as before. And the velocity we just calculated. Now if we go through, 0.5 times 0.4 is 2 kilogram meters per second, plus 0 will equal 0.5 kilograms times the velocity is plus the square root of 2 over 2 kilogram meters per second. We can subtract from both sides the square root of 2 over 2 kilogram meters per second. And so we end up on this side with 2 minus square root of 2 over 2 kilogram meters per second equals 0.5 kilograms times the velocity. Now we can divide all terms by 0.5 or multiply all terms by 2. And so we get 4 minus the square root of 2, and this cancels out the kilograms too, meters per second equals the velocity. And this is in the x part. So now we have our velocity in the x direction equals 4 minus square root of 2, 2.6. Now we have to do the same thing in the y direction. So we go through the same way. The sum of the momentum 4 equals sum of the momentum after m1 v1 not plus m2 equals m1 v1 plus m2 v2. Now we can plug in the mass of the first object is still 0.5 kilograms. The velocity in the y part initially, all of this velocity is going in the x direction. So that means it has no velocity in the y direction. So times 0. Similarly, the other ball is stationary initially. So it is also 0. In the after part, the mass is half a kilogram times the velocity of 1 plus half a kilogram times the velocity in the y direction, which we know is 2 meters per second, or square root of 2 meters per second. 0 times 0.5, or sorry, 0 times 0.5 is 0 plus 0 equals half a kilogram times the velocity plus square root of 2 over 2 kilogram meters per second. You can subtract both sides by the square root of 2 over 2 kilogram meters per second and move it over to this side. It'll be a negative square root of 2 over 2 kilogram meters per second equals 0.5 kilograms times the velocity of 1. We can now divide both sides by 0.5 kilograms, and this will take out the kilograms, and it'll take out the 2 underneath, so we end up with negative square root of 2 meters per second equals the velocity in the y direction. We can add that over here. This is the velocity in the y direction, and we can approximate it to 1.4 meters per second. Now we have all we need to calculate the angle, which is what we are looking for in this problem. So we start off with the x direction. We calculate it to be 2.6 meters per second. And then in the y direction, sorry, this should be a negative, we get negative 1.4 meters per second. And the negative just means it's going down instead of up. And we are looking for the angle theta here. We can solve this with tan theta equals opposite over adjacent, negative, except the negative goes away because now it's a triangle. So 1.4 over 2.6. And so our theta will equal 28 degrees.